Okay, so today I'm going to be talking about a scenario where you have two sorted lists. Um, so the input, so the input is going to be two sorted lists. So say list A. Okay, I'm not really good at guessing random numbers, so stars are just going to get same multiples of two. So 2, 4, 6, 8, maybe 9, and maybe list B, which again is going to be sorted. And then so let's say it's going to start at 4, 5, 6, 7, 8, 9. Okay, so the challenge that is now being posed to you is find the list of like create a new output, and the output is going to be the numbers that appear both in list A and in list B. So maybe try to think about this from how a naive approach might look like. So maybe let me just start by copying this out here. So how would a naive approach look like? You might decide, okay, what I want to do is compare each number to each other number to find if there's some commonality. So I'd start with 2. Just continue. Let's do this. You can continue all of this. Just check, check, check if it exists. This might not be necessary because we already know that this list is ordered, so maybe we can skip and just start at 4. So now we already know that this list is ordered, so there's no need to look at this, and instead we can start from here. However, there might be a scenario where let's say there are like multiple repeated numbers. So let's say we had then here we had a 9 and a 9 again, so we can't even once you've checked the 9, you need to check the 9 again. So in this particular scenario, I'd look at, okay, I'd check the 4, then I'd check the 4 again. If the 5, okay, we have gone up a number, I don't need to check that again. Now, a couple of things you have realized in this conversation. The first one is that many times I've said you can just check the first number to make sure that if that number exists, there's no point in checking it again. And once you have moved to a greater number, there's no point in continuing to check. So if I had a list that looks something like this, right? So this one went all the way from 2 to 9, and this went all the way from 4 to 9. In effect, what we're saying is, this is how this would look like probably. In fact, what we're saying is anything past this, we don't even need to check. If for one reason or another this number was smaller, so assume this number stopped here, that means anything past this we don't need to check. So one of the things to kind of sorry, let me just repeat that. So here, anything above 8, because this area is not common, we can remove. Anything below this area we can also remove. So the idea here is that we can almost in a sense be reducing the problem as we proceed. And that's one of the things, whenever you find yourself in a situation where you are doing double work, or you find that you can reduce the problem, then always do that. All right, so then how do we go about it? So let me just paste my number again here. All right, so how would I go about finding this number? The first thing is I want to make sure that I start my array, and I want to so one thing that I want to do is, instead of checking from only one point, I want to be able to check from 2 points. So basically what in effect I do is that I set a pointer here, I set a pointer here. Now this is almost the start point. So the next thing I want to do is quickly check, or in this, because now I'm at, both of them are at point 0. So I want to check are the numbers the same? If the numbers are the same, then obviously we have a result, and this is our result array. For example, this is our result array. So if the numbers are the same, 2 and 4, then we would put in a result here. But we know that that's not the case. So the next thing we check is which of these two numbers is smaller. So we see then the top number is smaller, so we can in effect remove that item and add 1 here. So now pointer is at 0.1. This pointer doesn't move yet. And then we see, oh yeah, so these numbers are the same. So now I'd pick up 4. Once I found that number, I'd advance both. So I'd advance both. But now this is now at this point, this is now at this point. Again, I do the comparison. Are the numbers the same? No. Okay. So the numbers are not the same. The next question is, which number is smaller? So this number is smaller. All right. So then this one needs to be removed. We move the pointer 1 step up. This one we leave it as is, and then we compare, are these two numbers the same? And the answer is yes. So then I'd put that in, and I'd move both at the same time to the next one. So I'd proceed in this fashion until I go to the end of it. I know that this is guaranteed to give me the right results for several reasons. The first one is that everything left to the pointer has been looked at. Everything right to the pointer has not been looked at, and this is true both. This is true both ways. And then I also know at any point in time across both, we have already hit the minimum number across both of them, because they are A, an ordered list, and B, that's what the process has been. So I've been checking what's the minimum. Right, so that's how I'd start. So how would this look like in actual code? So then maybe I'd have something that looks like this, def, and then I'd have maybe array1 and then array2. Okay. Now the next thing I want to do is I want to find the pointer. So they both start at 0. So let's say pointer 1, we're going to just call it I, starts at 0, j starts at 0. So for both arrays, we know we start at the point 0. The next thing that I want to do is make sure that we have not. So the question I'll ask myself is, how would the loop terminate? So how would we know we have gotten to the end? So how would we know to gotten to the end is if, so do like this, while I is less than, want to check the len of this number, and the len and j, which is now what we're using as a second tracker for array2. Now we know that this will, because the arrays are 0 indexed, so this shouldn't be a problem. We won't get to the out of bounds index just because of that property, and because we aren't taking equal to, we're taking less than, so we know we will not hit that. We will not hit that scenario. So the len here, so if you look at this, the len will be 1 2 3 4 5 6. So we know the len will be 6, but we know the index will start from 0, so the index will be 5. So when you hit this point, the loop will stop, and that's what we want. Okay, so that's a good place. And the next thing is, remember, we were advancing these arrays, so we were checking which of these. So we're checking if the numbers are equal. That's the first thing. So we check if the array 1 at point I is equals to array 2 at point j. This is like an equal sign. So we want to check. So if this is the case, then actually need to create a new result array here. So if this is the case, then what we want to do, to append to this result. All the things that I can do is just make it a set, because I know the answers should be unique anyway. So I can do like result dot add. Now I know that these numbers are equal, so it doesn't matter what I put in. But what I do know is after this both of these numbers need to advance. So then I'd say I plus equals 1, j plus equals 1, and then it continue. So that's that part is done. We have handled this case where they are equal, but you want to see the case where this one is actually greater. So if the array at point I is greater than the array 2 at point j, okay, then at this point in time remember it's the smaller one that we advance. So j plus equals 1 else. So else I would have covered two cases where they are equal or one where it's smaller, but we have already covered the equals here. But I mean, for the purists out there, if you do prefer to actually have a good sense of that, maybe I can do an elif. Then I can say, okay, so now I have an elif the other way around, right? Ri is R2j, okay? Then now do plus equals 1, and then this would continue. So this would continue until it will find something, and then eventually we can return the result. So this would be sort of my approach if I was trying to find a situation where I'm trying to find both arrays or the common elements in the two arrays, and the arrays are sorted. I should mention that probably if array 1 and array 2 are not sorted, I'll probably start with sorting it first. But if someone has an approach that would work with the arrays not sorted, I'm also very interested in knowing. Thank you.